Okay, for tonight's homework, I'm going to quickly review how to dilate one of these through the origin, and then the big thing, using the lengths of this triangle to prove if they are proportional or to prove scale factors. I also want you to write down the 5 words that show that you watched this for sure. Alright, so again, some of you will start to get to the point where you do not need to draw the dilation lines. You do not really need to, but just keep in mind you need to draw the dots at least. So going through these points through the triangle again, following that pattern of slope, over 4 up 2, over 4 up 2, over 4 up 2, drawing my line through those best I can, and then doing the next point. Going through points B, it looks like I'm going right 4 up 3, right 4 up 3, right 4 up 3. That's going to be the pattern through the origin through point B. Right 4 up 3, right 4 up 3, right 4 up 3. Draw that line best you can. Eventually you won't need to draw those lines, but just draw those dots at least. And then the last one, C, going over 7 up 2, over 7 up 2, over 7 up 2. And then drawing that line and knowing that each point up each line will show you the new location for the bigger triangle as it gets dilated bigger. So when I draw line C, or the line going through the origin through point C on my paper, each of these dots, the next one up, will show you where you're drawing the next triangle location. So from here is 1. So if I double each of these lengths, I end up doubling the shape. Doubling these lengths along these lines will dilate the shape and double it. We'll times it by 2. So again, along these dots, further up each line following that same pattern, over 7 up 2, over 4 up 2, over 4 up 3, that will be the new location of my triangles as it gets dilated out. So this first one multiplies by 2, doubling the distance down these lines, doubles the size of the shape. Tripling the length of this, going triple this length. 1, 2, 3 of them will triple the original size. Tripling that length, 1, 2, 3, all the way to here, triples the size. And the last one, quadrupling 4 times this length. 4 of those, 1, 2, 3, 4 times, creates a triangle 4 times the size of the original. 1, 2, 3, 4. 4 of these, 4 times, creates a triangle dilated with the same proportions, but 4 times bigger. Now, eventually, the triangles you might get without the lines going through them. So here I believe I drew these best I could with the lines going through them being erased. So now I'm going to find all this stuff by using just lengths. The first word is girl. Girl. So all these lengths. This triangle is 3 boxes long. This triangle is 2 boxes high, 6 boxes long. 3 boxes high, 9 boxes long. 4 boxes high, 12 of those boxes long. And just be careful when you're counting. From here isn't 1. From here to here is 1. So don't be counting 1, 2, 1, 2. That's how I'd like you to count. So I want you to use just the lengths. The second word is boy. Boy. So to find if they're similar, I'm going to label each triangle so I know which triangles I'm comparing to each other. And again, I'd like you to have this work copied on another piece of paper. Copy this work down and write the words. I'm going to compare triangles 2 and 3. Those are just two pairs I picked. So if I pick 2 and 3, I need to put the number of those lengths in the proper spots to make these two fractions equal. Or if I put them in there and they're equal, it proves these triangles are similar. So I'm going to show you some patterns I could choose. I could go 2 over 6, the height over the length of the small one, as long as I set that up as the height over the length of the big one. That's true. That's 1/3. That's 1/3. Other ways I could do it. The third word is toy. Toy. Another way I could do this would be to put the 3, the length of the tall one over the length of the little one, as long as I did the length of the big one over the length of the small one. Again, those are equal. I could do it another way. I could do it 6, the length of the small one over the height of the small one, equal to the length of the big one over the height of the big one. I'm going to do 2 over 6 equal to 3 over 9 and show those are equal. So 2 over 6 and 3 over 9, if I divide both by 3, that reduces down to 1/3, and this reduces down to 1/3. Those are equal, shows these are proportional triangles. They're similar. Scale factor. I'm going to do a couple here. So I'm going to do from triangle 2 all the way up to 4. I'm also going to do from triangle 2 up to triangle 3. So if I go from 2 up to 4, making it bigger, dilating it bigger, to find that scale factor, it's always the new length of the triangle after it's been made bigger over the old length, the length of the triangle before it was made bigger. So if I'm going from triangle 2 to 4, I could use any of these lengths here. This 12 and this 6, this 4 and this 2. So I'm going from 2 to 4. So the new length, using these bottom pieces here, is going to go from 6 up to 12. So my new length is 12. That goes on top. My old length is 6. So this scale factor from triangle 2 to 4 is 12 over 6. The new length, 12 over 6. And if I divide that by 6, 12, the whole number divided by 6 gives me 2. And that makes sense, because this triangle doubled gives me these lengths. 2 times 6 times 2 doubled. Doubled. Makes sense. From 2 to 4, the scale factor is 2. Everything doubled. If I do from triangle 2 to 3, so again, from 2 to 3, from this one to this one, the new length divided by the old length, or the new height divided by the old height, whatever numbers you want to use. I'm going to use the bottom numbers. So it goes from the original 6 to 9. So 9 is the new length, 6 is the old. This fraction can't be reduced evenly, but it can be divided down. So if I divide both top and bottom by 3, that reduces down to 3 halves. So this triangle is 1.5 times bigger than triangle 2. If I'm going smaller, and again 3 halves is 1.5. The fourth word is blue. If I go down from 4 to 1, shrinking, going down, shrinking, 4 to 1. Again, it's the new divided by the old. So if I'm going down from 4 to 1, using these same lengths, I'm going down from 12 down to 3. So the new length is 3. From 12 shrinking down to 3. I put that 3 on top because that's the new length when it's shrunk down from 4 to 1. So 3 on top, and then the 12 on the bottom. From 12 to 3. 3 is the new length. 12 is what it used to be. 3 over 12. That reduces down, when I divide top and bottom by 3, into 1/4. And that makes sense, because these multiply by 1/4 which is the same as dividing by 4, gives me 3. 4 times a fourth, which is the same as dividing by 4, gives me 1. And then, of course, if I do triangle 4 to 2, that 4 to 2, original 12, shrinking down to 6. Or 4, this length, shrinking down to 2. So again, I could use length or height. So again, from this 4 to 2, start at 4, going down to 2. 2 over 4, that reduces down to a half. So this scale factor from 4 down to 2, I'm timesing by a half. 12 times a half, if I go back to that. 12 times a half is 12 divided by 2, that's 6. 4 times a half, that's 4 divided by 2, that's 2. Going down here, 12 times a fourth is 12 divided by 4 is 3. 4 times a fourth is 4 divided by 4, that's 1. Going the other way, 3 to 12, scale factor is 4. 3 times 4 is 12. 1 times 4 is 4. Got to understand that. The fifth word is dog. Dog. Good luck.